Good afternoon. Happy Tuesday. I'm happy to see all of you. Couple reminders. 1, Unit 3.1 classwork is due on Friday. Culture Night's on Thursday, so I hope to see you there. In terms of our agenda, we're going to start with a brief write-up, just to practice some concepts that will help us with the Pythagorean theorem, which is what we're learning today. We'll talk about the history and applications, dive into some notes, and do some whiteboard practice. Here is your Unit 3 breakdown. Unit 3.1, we're talking about Pythagorean theorem this week. Next week, we'll talk about trig ratios. Week after that, we'll dive into law of sines. And the week after that, we'll talk about law of cosines. Your next exam is Thursday, November 6th. So here's your do now. So I would pass out some little papers to all of the students, and they would have a couple minutes to try these problems. And then I would do the problems on the board. I would pass out the guided notes. These guided notes are linked into the turn-in for you to see. The guided notes are fill in the blank to help accommodate for those students who need differentiation. I would do a think, pair, share and ask the students, what is a right triangle? I would give them about 30 seconds to think independently without anyone talking, and then I would give them about a minute to collaborate with their peers, and then we would talk about it. What is a right triangle? This is a vocabulary term that we have not used yet in this class, so we would dive into it. Here are the components of a right triangle. A and B, they represent the legs of our triangle. These are attached to our 90-degree angle. A right triangle has a 90-degree angle, which is represented by a square. C is our hypotenuse. This is the only side of our right triangle that is not touching that 90-degree angle. What is the Pythagorean theorem? Can I please have a volunteer from the class read this aloud? So then I would have a student read this. For any right triangle with sides A and B and hypotenuse C, the square of the hypotenuse is equal to the sum of the squares of the other two sides. I would have the students write this formula straight into their notes. I really like this visual because it can show you how the sum of A and B being squared equals C being squared here with the squares. I don't go too much in depth into the applications of the Pythagorean theorem because we won't be utilizing that too much in this class. Now we're going to dive into the history of the Pythagorean theorem. So here are the ancient roots. They go all the way back into before the 6th century BC with the Babylonians. They had advanced knowledge of right triangle ratios, and they used this for practical land surveying, managing property boundaries, and construction. And we can actually see a tablet here which reflected these triangle ratios. The Egyptians used these triangle proportions as well to construct right angles for pyramids. So I ask you, and I would do a think, pair, share here, why might right triangles assist Egyptians in building the pyramids? So they would think about it for 30 seconds, talk about it for about a minute, and then we would talk about it as a class. So we can see here, if we could figure out how tall the pyramid is from O all the way to the ground, we can clearly see how far away we need to build each slant. So that's kind of what we would talk about there. In Asia, from 800 to 400 BC, in India and China, I'm not going to pronounce this word because I'll pronounce it wrong, but this is where we found their math for these formulas, the Pythagorean theorem. And they used this formula to calculate the lengths for architectural and religious purposes. In southern Italy, we get Pythagoras. This was in 6th century BC. He taught this principle, and his followers, known as the Pythagoreans, mainstreamed this theorem in Euclid's Elements, which is a scripture here. So we're going to do a couple questions now. Here's your first one. Based on this brief history, do you think it is appropriate for the Pythagorean theorem to be named after Pythagoras? We would do a think, pair, share here. Why do you think the theorem was named after Pythagoras? as opposed to other mathematicians. Here I would talk about the racism of the time and about how Europeans thought that their knowledge was better than knowledge of other cultures during this time period. Besides the applications that we talked about, what other ways can we apply the Pythagorean theorem? I'd have the students do another think, pair, share, let them brainstorm before presenting this slide with some different applications. We have road transportation, airlines, robotics, mechanics, and electronics, and we would go into depth with some of these. So how do we use the Pythagorean theorem? First of all, we need to determine which side of the right triangle is missing. So if one of the legs is missing, again, that is labeled with A or B, then we plug in the leg value for A and the hypotenuse value for C to solve for B. I can't write on this, but I would write out the formula here to show what that looks like, to give them an example. But if the hypotenuse is missing, remember that is the side of the right triangle that is not attached to that 90-degree angle. We would plug in the leg values A and B and solve for C, and I would show that here as well. I have a couple questions on the slideshow, and they have this on their guided notes as well, and I would go through a couple of examples with them. Once I feel confident that they have a basic understanding, we would do this on the whiteboards as well and give them some practice. That is off pencil and paper because I find that it helps engage them as well. And that's what I have. There is two things I would like to mention. One is that the classwork for this assignment is more applicational than the notes. I will in the future be giving them a word problems tips paper, and we'll be going through it and practicing it the next day after this lecture to practice going through an applicational word problem. And then we'll see that on the classwork, which I have also turned into this assignment. And then the exam has also been submitted into this assignment as well, so you can see the applications as well. Thank you so much, and I hope you have a great day.